the results. Then I'll round up the session with a question and answers. And please, if you have any questions, do have use the chat function or the message function on the system. So I'm going to hand over to Enrique now, if I can stop sharing. There we are. I'm going to hand over to Enrique, and he can present the...
Hi to all, my name is Enrique Onieva, and I'm the coordinator of the LOGISTAR project. So with this presentation, I want to provide you with an overview of the project within this event. So LOGISTAR, the team is composed by a consortium of 16 partners that is coordinated by the University of Deusto here in Spain, and with an approximate budget of 5 million euros. The duration of the project is for 40 months. Actually, it's going to finish soon, this September. And it's a project that is managed by the INE agency, the Innovation and Network Security Agency of the European Commission. The project receives funds from the H 2020 program, actually for the work program Smart, Green and Intelligent Transport, and the call named Innovative ICT Solution for Future Logistic Operations. In this slide, we can see a schema of the overall concept of the LOGISTAR. LOGISTAR aims for effective planning and optimization of transport operation, relying both on horizontal collaboration and also on real-time available data. So it is going mainly to derive two services, one on the call control and decision-making tool, and the other one real-time information on freight transport. The first one is composed by two sub-services that are named Integral Visibility and Planning of Resources and Planning of Dynamic Routing. So the idea is these two global services are going to orchestrate different elements within them, like those related with the optimization, the identification of events, the replanning due to incidents, also the horizontal and vertical collaboration, and the management of multimodal fleet. Also for the real-time information on freight transport, we are going to measure KPIs for real-time logistics, like the position of goods, the operation status, the working condition, arrival times, and so on. In this slide, we can see also a schema of the concept. We can see in this part of the slide, we have different data that can come through the system as broad data, like information related with the position and so on, and other information related with the Internet of Things, like the position of the goods or the status of the routes. This data comes through the system that is divided mainly in 4 intelligent modules. One of them is for the identification and management of events. Other one for the prediction of driving times or prediction of incidents. In the overall, for using artificial intelligence methods for predicting the future events on the supply chain. The third module is focused on the optimization of the resources, and then we have a 4th module for the automatization of the negotiation and re-optimization in case this is needed. Finally, the results of those modules are feeding the 2 main systems within LOGISTAR, the decision-making tool and also the real-time information. So the data in this overall workflow will be retrieved and also harmonized, and sensor will be connected to the cloud by the Internet of Things platforms. Also, we have 4 modules for smart algorithms. One of them focuses on predictions, the other one on learning the preferences of the stakeholder, the third one for the optimization of the planning of operations, and a fourth one for the negotiation and re-optimization in an automated way. So finally, real-time dashboard will give this information to the stakeholder. The project has 6 main key innovation aspects. One of them is the use of artificial intelligence for prediction. The second one is the use of global optimization planning, relying on realistic optimization model and also multi-objective optimization. The third one is for the automated negotiation and re-optimization, considering this like a constraint satisfaction problem. The fourth one is for the event identification rules, the fifth for the service layer, the decision-making tool, and the sixth one for the data gathering techniques. Extract, transform, and load tools for linked data, also considering the scrapping of the data and its transformation. All these modules will be tested through 4 different living labs. The first one is for Nestlé and Pladis, is focused on van hauling and co-loading in order to improve van hauling management and to the overall overview of the status of the operation. The second one is relying in synchromodality and also multimodality for the routes and also for the real-time monitoring. The third one is for the dynamic appointment scheduling and accurate estimated time of arrival calculation for trucks, with the aim of reducing the waiting times at loading and unloading locations. And the last one is the virtual living lab or stress test for the methods to use historical data in order to be able to see how the system behaves under extreme situation, like very high demand or very low use of resources. So here we can see a schema of the milestones of the project. So right now we are in the last stage of the project with the integration of the LOGISTAR platform within the different living labs. So right now we collected the user needs and system requirements, also provided analysis on horizontal collaboration and regulation aspects. We include data sources and also the storage for the data, the event processing modules, and also to implement the algorithms for predictions and for the global optimization and re-optimization algorithms. We have the architecture, the scene, design, and also the use case and validation plan. And we provide several actions related with the dissemination and the business models. Here we can see an overview of the 16 partners within the LOGISTAR. So the tasks are divided between the coordination, each one of the modules, like the global optimization, the artificial intelligence negotiation, the IoT data gathering, and so on. So here my presentation ends. So in case you have any question, you only have to contact us.
Thanks very much, Ulrich. I think you can see from that brief presentation about the project that it's really taking innovative academic research. There are 3 academic organizations involved in developing modules for the LOGISTAR system, taking academic research and putting it into a practical environment with organizations like Nestlé and Pladis, Arlas, Shep, and Codognoto and Zilog. So the next presentation is me. I'm going to give the presentation about the functionality of the system.
Good afternoon, everybody, and welcome to this session. We're going to talk about the system functionalities of LOGISTAR, how they were defined, and what the innovations are. So just a bit of background to start off with. We all know that how inefficient road transport is. We know that from European Union statistics that a quarter of all road freight vehicles are empty, and those that are full, only 2/3 full by weight. We also need to get goods off the road onto rail, and we need synchronodal solutions. And going back to 2006, we were involved in a project for the Department for Environment, Food and Rural Affairs, where we wanted to reduce the external costs of food distribution in the UK by 20%. And collaboration came out as one of the big opportunities for reducing the travel costs and travel time and travel distance. And that was adopted by the Institute of Grocery Distribution, who represent hundreds of FMCG members. And in 2010, they came to us and said, would you just evaluate and see if there are still those collaboration benefits? And we managed to get 27 fast-moving consumer goods companies from the members. They represented very large retailers, manufacturers, and wholesalers, and they provided us with very detailed flow data for the UK. And the data was phenomenal because it represented 8% of all road freight movements. And we identified lots of collaboration opportunities, even though the IGD wanted collaboration to be more they wanted collaboration to be encouraged among the members. And in 2014, we did a similar study, and this was with 10 companies. And again, we showed these real benefits. But of course, it hasn't really taken off because these were done at the strategic level. And what really came out was that companies, they didn't really understand how to do it in practice. They needed some system or other to support the collaboration in practice. And that's exactly what LOGISTAR has been designed to do. And of course, Alice, with the physical internet, the promotion of the idea of the physical internet, collaboration is a fundamental part of that roadmap. So all in all, this is why LOGISTAR comes about. When we started the project, it was 3 years ago. Obviously, we needed to get the functional requirements as soon as possible. And we started off thinking, should we look at focus groups? This was in the proposal, actually. But when it came to it, first of all, companies, it was very difficult to find a common time for lots of companies to come together to talk about collaboration. They didn't really want to travel to a central point to have this meeting because there was no real benefit for them. And thirdly, they were probably very reluctant to come across with sensitive information or information they wouldn't want to reveal to other companies. So in the end, we went and visited 22 companies and interviewed them in great detail. And you can see the discussions we had around the supply chain networks, the systems for managing the transport, and the transport planning. And you can see the various factors we discussed under those various headings. So we really needed to try and understand the way companies operated and what the issues were. And we focused around FMCG because that was one of the first living labs, the use cases in the project. The chemical sector, which originally was a living lab, but unfortunately didn't take place, and through logistics service providers, particularly for synchronodal solutions. You can see the ones in yellow there represent the stakeholders within the project. And under other, we had Toyota and Shep. And Shep originally weren't part of the living lab, but then joined us to take over from the chemicals living lab. And we really got to understand what the issues were and to help us with those functional requirements. And this was supported by a strategic analysis. You can see the 4 sectors we looked at because they corresponded with the living labs that are in this project. And we obtained flow data from the number of those 22 companies we interviewed. So in the FMCG sector, there were 5 companies. Nestle and Pladis are partners in this project. They provided data. and then there were 3 others, including one retailer. So it was very useful to have the understanding of vertical collaboration as well as horizontal. The logistics service providers we analysed were European companies with flows all across Europe, and looking very much at the opportunities for intermodal flows or synchromodal flows. And then we have the 7 terminals within Europe as well for that project. And then the chemical sector, where we looked at 7 companies. They were European companies as well. So the main reason for that strategic analysis was to really gain an understanding of the transport operations, to see the functionalities that could be used within LOGISTAR. The first 3 are really looking at the individual companies and to understand the data they gave us, making sure it was validated, and to really see the level of truckloads, the level of part truckloads, and so on. And also really to show the collaborative opportunities, to make sure they could to help them, to encourage them to take part in the LOGISTAR project. Because at the strategic level, it's clear that there are benefits, but if they're involved in the LOGISTAR project, then they could be part of the real-time system that's being developed. It was also to look at what the opportunities were for LOGISTAR, for collaboration within the LOGISTAR system, and then to see if LOGISTAR could find those opportunities, more to the point. So there's a whole range of different things within those strategic analyses. When we looked at the individual company, we did a whole range of different analyses. As you can see there, the high-level totals, the delivery and load analysis, the customer Paretos, regional densities, the synergies, with looking at synergies for the different the companies. And then we also looked at the centre of gravity and alternative vehicle type, just to see how efficient an individual company was, give them a bit of feedback on their operation. And then when we looked at the collaborative opportunities, not just looking at empty running or maximising vehicle fill through LTL, but we looked at co-loading, consolidation, looked at train and ship as well as road, looking at regional and urban consolidation centres situated in locations of high demand, and then logistics clusters where there were locations of lots of distribution centres perhaps. So those collaborative opportunities we looked at the strategic level, and the outcomes were that the key performance indicators can be improved. That came out. Obviously all the companies looked at key performance indicators, but really they felt that there were improvements to be had. They all expressed a desire for collaboration with other companies. Now this is very good that they want to do it, but they didn't really know how to do it, and that's why they were very much part of this LOGISTAR project. And some of you are here today attending this meeting that we had because you're part of our advisory board. So it's clear a system support was needed to enable this. Yeah, great interest in LOGISTAR, and the area that LOGISTAR would benefit are those companies that have control over their own and logistics service providers, transport operations. So it's not necessarily if you have an own transport operation, but it's where you have control over the transport operations. So if you just subcontract and let the logistics service providers do their own thing, then LOGISTAR wouldn't really be a benefit. The strategic analysis still shows opportunities to improve the efficiency of companies, and that's through backloading. You can see there, typically cost of just under 10% and CO2 just over 10%. Co-loading could save about 7% of cost and about 5% of carbon dioxide emissions. And the synchromodal flows, if you could use the optimum terminals, because again, companies would use terminals without really knowing which was the best one to use for cost, but they could also significantly save cost. For instance, one of our analyses involved looking between Italy and the UK, and there was over a 40% cost saving for rail over road. It goes without saying, it's almost common sense that you should use rail if possible to move long distances, in preference over road. And it's obviously much more cost effective to do so. So the requirements that came out with the LOGISTAR the fact LOGISTAR is, although it's a real-time system, it's not an operational system. It's a decision support tool that should be run in parallel with the company's existing transport management systems. So it hasn't got control over your operation, but it's suggesting beneficial routes, beneficial collaborations to complement the existing company's transport management system. The other thing is that parameters should be flexible so that they reflect manual load planners. For instance, Nestle and Pladis both use manual load planning because they feel they are much better at producing efficient routes than a vehicle routing and scheduling system, for instance. So a manual load planner will maybe take a slight pragmatic view over various situations. So whereas a vehicle routing and scheduling system saying this vehicle has to be back by, say, 5 p.m. to this depot, a planner will say, well, maybe 5 past 5 should be all right. So a bit more flexibility. And that's why within LOGISTAR, we have a system that learns the planning preferences, that learns what the manual load planners do. And that's built in with machine learning and artificial intelligence, so that subsequent suggestions by LOGISTAR can incorporate those adjustments that manual load planners often take. There's a prediction there for accurate travel times using artificial intelligence and turnaround times. And we know that a lot of these systems out there have, commercial systems out there already have that sort of thing. But really, this is an innovative way of measuring accurate travel times, incorporating things like broad data. So you have, at the moment, it's fairly limited, but things like weather, road traffic congestion at different times of the day, at different days of the week, whether there's a sports event on or something like that that might affect travel times through a particular location. So that those sort of predictions incorporate those, or will incorporate those elements to try and make travel times much more accurate. And of course, there are also, when vehicles are on the road, there are real-time route updates when required in case there are delays or such like. So those are some basic planning requirements for LOGISTAR. If we go into the transport planning and dynamic routing element, first of all, the system is using various different optimization algorithms using a technique called constraints programming. And whereas conventional vehicle routing and scheduling systems will minimize, time or minimize cost, this system will minimize empty running and optimize vehicle fill. In theory, this should also minimize cost, but this is the main aim of the algorithm. Maximize vehicle fill, minimize empty running. And of course, this will take into account the offset distances if you've got to travel to collect and deliver. And in fact, that's part of it, is to have multiple collections and deliveries in the same route, which again, traditional commercial routing and scheduling packages have. And the way the system works is there are the LOGISTAR system will route vehicles for individual companies, and then it will put it together to find out what the collaborative options. So you have a cost and KPI comparison there. The key thing is with LOGISTAR is that it looks at all orders. It's not like a freight exchange system where you only put in selective orders for which you can't get a return load. One of the key innovative things is that you can't, you're not going to put in regular fixed flows for which you will get a regular fixed return leg. This is a dynamic system, so it's looking at orders from multiple companies on a daily basis. So collaborations can change daily. You're looking at the whole system, not just various flows for which there are problems with fill or with return loads. And then it's obviously looking at rail waiting and travel time for synchronodal operation. So we're trying to maximize vehicle fill, minimize empty running, and incorporate rail and sea travel times also. And then for planning re-optimization, again, this is a lot of commercial systems out there already have it, into things, devices on the truck, so you can monitor goods on the road. But that's part of this system, and the key part is there's various elements that already exist out there, and it's inevitable after 3 years of this project that commercial products will have been created. But there are already systems out there that do various parts of it. But the key thing is that all these elements are brought together in a single complete system. So there's event detection from IT devices. It receives updated route times from that prediction module, so it can actually convert or change routes or adjust the timings if necessary. And there's a dashboard display of information which comes across to the planners so they can see what needs to be done. So you've got a dashboard display for planning, you've got a dashboard display for rescheduling, and again, that will be discussed in the next session. And also there is an automated negotiation of planning re-optimization as well. Again, this is there is a talk about that in this conference tomorrow, but that's also part of the LOGISTAR system. So that's the presentation, and I'd just like to finish by just reiterating some of the things we've said before, because I've written a little section for a report which I think summarizes it very nicely, and also it'll make sure I haven't forgotten anything. So if you'll excuse me, I've got a short section to read. Although LOGISTAR is a real-time system, it is not an operational system. It's been designed as a decision support tool that supports a company's TMS. The functionality of LOGISTAR has been specified after discussions with 22 leading shipper and logistics service providers from a range of industry sectors, but mainly in the same sectors as the living labs. It's inevitable that after 3 years, other freight transport software will have been developed along similar lines and that contain the individual components we are developing, but not in the same way and not in the context of a collaborative system. The innovative part of LOGISTAR is the unique algorithms of these components and the way they are put together into a system that handles freight transport collaboration. Individual companies will plan their transport normally as efficiently as they can. It's inevitable, but it will be within the constraints of their own operation. So inevitably efficiencies will be missed unless all orders from all companies are included. So LOGISTAR doesn't just receive orders from companies which can't be planned efficiently. That would make LOGISTAR a freight exchange system for which there are many products available. LOGISTAR plans all orders from the collaborating companies. Then the real benefits can come from the economies of scale. Also, the LOGISTAR system is owned by the collaborating companies. Vehicle routing has been around for ages. There are loads of commercial packages available out there, very good ones, but rather than conventionally minimizing travel time or cost, the route planning in LOGISTAR is based on some innovative algorithms that uses a technique called constraints programming to minimize empty running and maximize vehicle fill, which in turn should minimize cost. The route planning algorithm takes all orders from the collaborating system, and doing it this way means that on a daily basis, there is flexibility to have different collaborations. So we'll be looking at the orders for each day. So LOGISTAR doesn't rely on regular fixed flows. When there is a suggested collaboration, how do you know if a multi-drop load is cheaper than individual companies doing it themselves? Common sense suggests collaborative load is better, but it needs to be shown to be better. So in LOGISTAR, it produces a set of routes as though the individual companies were delivering their own loads, and then puts everything together so it's clear the differences, what the cost and KPI benefits are. And all this based on empty running maximizing fill within a collaborative environment which also includes synchromodal options. The route planning is supported by artificial intelligence machine learning algorithms that produce accurate travel and turnaround times, taking into account historic data and continuing open source data, which is limited at the moment. There's also a preference learning element that registers the manual load planners actions so they can be used to improve the subsequent routes produced by LOGISTAR. I should add actually that also within LOGISTAR there is a Shapley value to show the best way of apportioning not just cost, but lots of other factors as well, distance, time, CO2 and so on. Plus there is a second part to LOGISTAR, which is to monitor the goods on the roads using IoT devices, which of course is fairly commonplace now. But again, it is the combination of components because LOGISTAR is constantly checking to see if there are any significant delays which may require a replanning of the loads. And this is all combined with synchromodality, which again also exists in commercial software. But it's the combination of all the other elements that makes LOGISTAR innovative. And it's also important to note that we have some big European companies in the Living Lab to seriously test out this system. So that's it. Thank you very much from me, and I'll be delighted to answer any questions that you may have.
So that was, thank you to me for that. You'll also notice that for continuity's sake, I'm wearing the same shirt, but although the background's different. So that was an explanation of what the functionality is, and I hope that's made clear. It's been some time since there's been the system has developed, has gone quite a long way. So I'm going to introduce now Christian, who's going to talk about how the actual system itself has developed and how it's moved on to the current state of play.
Hello, everybody. Welcome to this talk. I'm Christian Gengbach from Software AG, and I want to talk about the progress in the LOGISTAR system. In fact, I want to give you an update on the status of the LOGISTAR application. And my goal in this talk is to give you a good idea about the user experience of the LOGISTAR application at the end. So that's what I want you to take away, is how the LOGISTAR application looks and feels for the user. Now, the LOGISTAR system consists of many software components, but the two components being visible to the user are the planner module and the real-time monitoring module. And I will talk about this a bit more in detail later, but the basic idea is that planners and dispatchers from logistics companies go to the planner module to take decisions about whether they want to carry out collaborative journeys, truck journeys proposed by the system with other logistics companies or not. So this is something that happens before the actual journey could take place. And then the second important module is the real-time monitoring module, where when such a collaborative journey has been accepted and is carried out, the dispatchers can actually monitor them in real time, independent if the truck actually belongs to their company or to a different company. If it's their company, obviously their transport management system, which also show where the truck is, but in other cases, here is the place to look for the truck and to possibly even take decisions during the journeys carried out. A bit more about a little later. Now, in general, the LOGISTAR application is a browser-based system. So that means it's a web application. And with any browser connected to the internet, you are able to log on. You have a tight security with credentials and a role-based system where not everybody can do everything. So this is important because not any person logging to the system can see any detailed data of the orders carried out, because obviously there are different logistics companies looking at similar data, so we need to prevent each other from seeing every data. Once you're logged into the system, you will be able to access those two modules I talked about, the planner and the real-time monitoring, and we see that in a bit in more detail. In general, LOGISTAR application runs in the cloud on a server cluster, well protected by a firewall and other security measures. You are able to access this application with any device that is able to run an internet browser connected to the internet. And if you have correct credentials, then you can log on to the system. The system will automatically cater for the size of the device that you have. So whether it be a laptop or even a phone, the system will adapt its screen so that you can use it from both devices or all devices possibly. Before we look at how a planner or real-time monitoring would look like, I'd like to take a little look into the architecture of the system. And that's not, the idea is not to confuse you, but to give you an idea what the system is able to do and what it doesn't. So what you can see here is, besides obviously the user interface with the planner and the real-time monitoring, which is at the upper half of the screen, you especially can see the data sources. And if you look at the bottom of the screen, you see things like weather data, traffic data, timetables, routes, business data, which is in fact order data received from the different participating logistics companies, and then live data from trucks or other transportation means, from IoT sensors which are on trucks or on the goods themselves. And this is all data which flows into the system constantly. And it's all sorted and harmonized in the system, and the system constantly calculates especially from the order data it receives, possible collaborative routes with the intention to save cost or time or whatever, especially in the case we're looking at in saving space on tracks. So the goal is to prevent empty running or half empty, half full running or things like that. So that's the idea behind the system. But you have heard about that already in previous talks, and I will show you how it's actually done. So that's all I want to look at here. If you finally get to a device and successfully log onto the system, you get presented with this screen. Now, this is the entry screen, and what we've done to make this homepage a little nicer is we actually included the official web page of the LOGISTAR project, the LOGISTAR research project, that you can reach also directly from any browser, just to make it more pleasant and give you access to the general LOGISTAR information. But the interesting bit here on this screen is the blue buttons on the upper left, where you can actually directly access the planner module or the real-time monitoring. So if you would be a planner of a logistics company, you at this point click the planner button and are directly guided to the planner application. The planner application is your central point for taking decision about carrying out collaborative journeys or not with other logistics companies. So each participating company or each planner of a participating company can take their decisions individually and also independently in a timely manner. So they can do it in general. The idea is you do it like a couple of days before the actual orders are due. And you can do it at any time you log on to the system. You get presented with the current available collaborative journeys which have been calculated by the artificial intelligence within LOGISTAR. And based on all order information available, these collaborative journeys are calculated and presented to you. And that is what the planner module does. And the screen of the planner basically looks like that. You have a list of collaborative journeys. And so each row represents one proposal of the system. And here we have 7 rows, and you can see in this case we have participating logistics company are Nestle and Paris, both are partners in the LOGISTAR project, but this could be any other company and any number of companies. What a planner is supposed to do in the display is to look at every collaborative journey and take a decision for that journey if his or her company is willing to carry that collaborative journey out, or if they rather do the orders only by themselves on their tracks. And the way that you take that decision is by clicking on the far right side where you see the column titled Own Decision. And a little left from there, you see the green check marks that you see accept and reject drop-down boxes. And whether you want to accept or reject, you choose the drop-down box, and you are able, especially for the reject case, to select the reason why you want to reject, so that the system is able to learn your preferences even. So if you say, well, I don't want to do this because blah, 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 then the system has that reason and can take it into account the next time it does the calculation and the proposals. Now, before I go into more detail how you can actually take those decisions and what information is available to you to take that decision, I want to show you the middle column, which is titled All Decisions, because that gives you a status information about that collaborative journey. And if you see a green check mark here, this basically means every participating logistics company has taken a decision and all have accepted that journey. And only in that case, you get the green check mark here, and that means this journey can be carried out. If you get a little yellow clock, like in the first line, that means not everybody has taken their decision yet, and the system is basically waiting for the decisions of those who haven't taken their decision yet. And the third status collaborative journey could be in is it's rejected, and that always takes, you get a little red cross in the same column, and that always happens if one participating partner rejects a journey. So if any one partner rejects a journey, the full collaborative journey is rejected, and nobody else can change that. All partners must accept. Now, if you double click on any individual collaborative journey here, you get presented with more details about that journey, and that might look like that. Like for here we have the details for the first journey, and you see a lot of details. I don't want to explain everything. You see on the left side a lot of order information. Basically, what I want to show you is the panel on the middle right side, which says KPI, and there you get information about the individual KPIs like distance or time it takes, and it shows you if this particular KPI is better, then it's green, or worse, then it's red. If you either take the collaborative journey or the non-collaborative journey, which means you carry your orders out by your own trucks and yourself and not participating in any collaborative journey. So that is the information that's available to you to take your decisions. And experienced planners immediately understand what's going on and can very quickly take their decision about all collaborative journeys proposed by the system. So that is where, like, a planner of a logistics company would log in, like maybe once a day. It will take him a couple of minutes to take his decision or her decisions, and then he will log out again. And then the system later will show you which collaborative journeys actually are taking place and which are not. Now, for those which have been accepted by everybody, these journeys are carried out, and the data when it's carried out and by which operator is all available here on this display. Once it's running, then you can follow on the journey in the real-time monitoring. The real-time monitoring module is a a display of geographical data, so it shows a map and a lot more of information about the collaborative journeys. And this is things like where is currently the track on the map, and you can zoom in, and we will see that in a bit. You see all the collaborative journeys. You can select the different orders of that journey. You can see the individual orders going from where to where, and you basically see the track live on the map. And the display on the right side shows you the whole journey and individual events during that journey, or where the truck should be, when, and where it is actually. And the other important thing that you see here is pop-up messages about disruptive events. So if like there is a blockage on the road, or heavy traffic, or very bad weather conditions, or things like, for example, even ships, vessels that don't sail but you are booked to, or trains that don't ride for whatever reason, then you still are able here, the dispatcher, I mean, it's able to even replan parts of the journey. So that's one important thing here, that you actually can follow the truck with your orders, even if it's not your truck, but it's a truck of a different logistics company. So drilling down is possible up to the real location where the truck currently is. And here's an example of a truck being at a delivery station where it loads or unloads. But I think, and I hope that I could give you a good idea about the user experience of the system, and that's the idea on one side of the simplicity to use the system and the security, but on the other side also like the broad possibilities to making the collaboration with other logistics company work. The last slide just shows you the 16 partners within the research project LOGISTAR. Also, what you see here is a link to the website that I mentioned earlier. So there you can get even more information, and also a short video that explains in a very nice way the capabilities of LOGISTAR and the LOGISTAR application. At this point, I come to the end of the talk. I thank you very much for your time and your interest in listening to this talk, and I wish you a pleasant day. Thank you very much.
Thank you very much, Christian. I think you'll see that the functionality has been turned into a fully fledged system now, and a working system of sorts. It's just gone into its very first test a couple of weeks ago with Living Lab 1, but I'm going to hand over now to Miguel, who will be talking about the Living Labs and what we've done so far. Thank you.
Hello, everyone. My name is Miguel, and I will talk a little bit about the use case description. So, as explained, within LOGISTAR, we have defined a couple of living labs where we will test the different algorithms and components developed in the LOGISTAR system. The agenda for today consists out of 4 living labs that I will briefly explain in terms of scope, challenges, and solutions that LOGISTAR brings. And then we'll have some time for Q&A afterwards. So to start up, let's have an overview of the 4 big living labs that we have identified within LOGISTAR. The first one is a living lab consisting of backhauling and co-loading opportunities that we will find for 2 of the biggest FMCG companies, being Nestlé and Pledis. This living lab is mainly situated in the United Kingdom, where we will try to look at real-time algorithms to find backhauling and co-loading opportunities for both companies in real time. Secondly, we have a use case around synchromodality, where we will use real-time replanning due to disrupting events in a synchromodal route. This route is mainly going from Italy to the United Kingdom, where we will try to re-optimize every time certain events happen during the route. Thirdly, we have a use case where CHEP is involved, and this use case is mainly situated in Spain, where we will try to reduce waiting times at the CHEP service center close to Madrid. Finally, we have also identified a virtual living lab where we will test, or where we will stress test the system to understand how far we can go with the algorithms and where the limitations lie. Now let's kick off with the first use case, being the Nestlé and Pledis use case. Now, to understand the Nestlé and Pledis use case, we should go back around 12 years in time, because at that time, Nestlé and Pledis were not really collaborating yet, and they noticed that there were quite some empty kilometers in their system. So what happened was, and it was actually quite a funny story, because that occurred at a coffee machine, transport planners of Nestlé and Pledis talked to each other and find out quite soon that they had similar lanes where they could find backhauling, co-loading opportunities and start collaborating horizontally. So what they did was they identified a certain lanes, like for example, from York to Barton, from Halifax to Barton, and from Melksham to the Midlands, to really set up a pilot use case. And this pilot use case is actually still running now for more than 10 years. The issue we have today, or the incentive we have today, is that there's still a lot of empty running in the networks of both Nestlé and Pledis. And even though they have set up this successful pilot, they want to take this to the next level. So therefore, they have decided to collaborate in this horizontal collaboration project to really understand where the opportunities within both networks lie and how they can use the LOGISTAR or smart algorithms that are developed into LOGISTAR to really understand what is happening and to have real-time opportunities presented to them while they are in the planning phase. So essentially, any of these incentives that we still see, empty running, a reduction in environmental cost, these are the incentives to really start working together on a more structural basis. And for what we believe is that for this structural basis, we really need some technology to do so. So that's where LOGISTAR comes into place. And actually, this is what we're currently testing. Now, the expected outcome of this living lab is, of course, to decrease quite some of the logistics service and cost KPIs that we have identified prior to the project. Think of empty running, where we'd like to reduce the empty running drastically. Think of asset utilization, so not just trucks owned by Nestlé and Pledis, but also drivers. Think of vehicle fill, and that will undoubtedly lead to costs and delivery timeliness. So to conclude, actually what we're trying to do is extend that pilot with a more optimized and technological approach to collaborating by identifying new collaborative opportunities for both Nestlé and Pledis that they can accept and reject using the system, and that they can then track and monitor along the way while they are delivered. Secondly, we have the use case of Zilog and Codognoto. So to describe this use case, we should first look a little bit at the different actors involved. So Zilog is actually the terminal operator in the port of Verona, where their trains leave. And what we see is that Codognoto uses this port to really get goods going to anywhere in Europe, basically, starting at the port of Verona, but then moving to any country in Europe. In this particular case, we're looking mainly on goods going from Italy, using different ports, not just different terminals, not just the one in Verona, and then going to the UK over different intermodal connections. Of course, there are quite some operators. We have the railway operator that communicates train delays. We have the terminal operator that communicates capacity or out of capacity constraints. And then finally, we have traffic jams, making it a difficult problem to solve because there are so many uncertainties in this whole chain that we would like to have also some visibility in it so that the different actors involved can also quite easily understand what is happening and react more quickly. So what we're actually developing is a track and trace system together with an optimizer. So the track and trace system will allow us to track where goods are and to gain more visibility in real time while goods are on different intermodal connections. Secondly, we're also looking at an optimizer that can identify, depending on a specific daily situation, think of road networks, think of predictions on what is going on, predictions on arrival time, train delays, etc. That taking into account all of these different parameters, that it can predict the most optimal route to get from Italy to UK. So again, and this is quite different than the previous Nestlé and Pledis case, because in this case, we will look at the environmental constraints and try to select the best plan for the different operators. And when this plan is selected, we can monitor in real time and gain visibility on where the cargo is, but also on what is happening during the transportation and the handling. Again, some KPIs that we would like to track. We, of course, want to increase the loading factor. We want to reduce delays, or at least understand where delays are happening and try to solve them earlier than as early as possible. We want to go for more modal shift because that modal shift is important. Switching to train is, from an environmental perspective, very important as well. And then finally, we want to reduce waiting times because right now we see that a lot of waiting times are happening just because all of these different actors are not talking to each other in the correct way. So in this living lab, the LOGISTAR system will provide a lot of visibility to all the stakeholders involved, and it will help them to optimize the different routes to get from origin to destination. Coming back to the third use case where we have CHEP, the CHEP story is actually more about the service center. So it's more an internal logistic operation, but in terms of planning problem and actually what we are trying to optimize, the mathematics behind it is quite similar compared to the first three cases. So again, the actors involved, in this case, is CHEP. CHEP is a commonly known pooling partner that collects the typical blue pallets. Now, they manage, maintain, and transport more than 330 million platform crates and containers, and these are shared and reused by different companies in the industry. So looking at the supply chain, it's basically very simple. The blue CHEP pallets go to the manufacturer. He uses it to bring it to the retailer. And then from the retailer, it goes back to CHEP, to the service center, where the pallets are maintained, controlled, and then sent back into the system again. Now, every day, CHEP is delivering, collecting, and relocating more than 4.5 million pallets from and to the 240 service centers in Europe. And that's actually quite a substantial amount of volume. And what is known as well is that CHEP is actually quite known to facilitate collaboration, because as they are carrying a lot of different companies, their pallets, collaboration or horizontal collaboration becomes a crucial part in their supply chain. Now, if we zoom in on one of those service centers, and this is the one in Fuenlabrada, which is in Madrid, then we see that within this service centers, there's also room for improvement. And the real-time monitoring, the real-time track and trace capability that LOGISTAR has will allow us to predict when trucks will arrive and to more efficiently manage the different loading and unloading areas we have within CHEP. So that will allow us to have a more frequent throughput time at this Fuenlabrada service center, allowing us to improve the internal logistics and actually facilitating, let's say, the horizontal collaboration capabilities of CHEP in that sense. Now, from a practical point of view, this more or less will look like this, where we have the different loading bays on the screen, and where we can more efficiently plan different trucks arriving and making sure that waiting times at the service center are limited. Now, if we look at the expected outcome, it is, of course, important to decrease the waiting times at the service center. We want to have improved yard efficiencies, which are directly linked to CHEP's costs, but also it will help them to improve customer service, because customer service will be improved as trucks will have a better throughput through the logistics site, meaning that they will lose less time and will arrive more precisely and at the right time at the customer. And this is actually one of the main blockers for horizontal collaboration projects. So that will remove one of the main blocking factors, let's say. So this is the CHEP use case. Again, it's a totally different environment, but still the smart technology that is developed within the LOGISTAR system, think of predictions, think of an optimizer, and think of a replanning tool. This allows us to also quite efficiently manage these type of problems. So, and then finally, we have the Allers use case. The Allers use case is actually about the virtual living lab. Why is there a virtual living lab? Well, actually, what we wanted to do is making sure that we could also stress test the system. So when looking at an Allers perspective, we have quite some customers, or Allers has quite some customers for which they do network optimization and simulation. So what we tried to do was integrate the collected data sets to make sure that we could stress test all of the algorithms and making sure that we could plan backhauling and co-loading opportunities and make sure that bigger networks can also carry out the algorithms that LOGISTAR is managing. So to give you an example on the data that we are simulating within this virtual living lab, this is a good example. So we've actually simulated in this whole pool of algorithms that LOGISTAR consists of, the different, this big network, which is basically delivering the full European network. I don't think there are any countries that are forgotten here. There are quite some different distribution centers and production sites from which deliveries are made in Belgium, Germany, and Italy. So in that sense, the volume of this virtual living lab gives us a massive amount of data that allows us to quite easily stress test the system. And again, even though here we will not directly put wheels on the road, because this is more of a historical data set that we are rechewing to make sure that we can get some visibility out of it and to make sure that we can understand what LOGISTAR can or cannot do. But this allows us to also measure the same KPIs that we were trying to improve when looking at the other living labs. So again, empty running will be decreased. We're gonna improve asset utilization. We're gonna decrease vehicle idle time, improve on logistics costs, and look at carbon emissions to make sure that is solved. Now, the final point where we test the timeliness of deliveries, that will be a rather tricky one. of course, because we are not putting actual trucks on the road, so we cannot really simulate the circumstances. But there we will make use of the amount of data that we have to really stress test the system and simulate what is possible. So coming back to my conclusion, to give you the goal of the presentation was to give you a flavor of the different living labs we have. I discussed, or I explained, the 4 different living labs, and when you look at the point of view, even though we're using the same technology, the use cases for which we are using it are quite different. We have one where we focus really on planning, horizontal collaboration opportunities within the Nestle and Pladis use case. Secondly, we have one that focuses mainly on synchromodality and optimizing intermodal connections. And then thirdly, we have internal logistics that we are actually optimizing using the same algorithms and the same software components. And then finally, we have the virtual living lab that then stress tests the system. So in short, I think that's a short overview of what we have in the different living labs. At the moment, just as a concluding note, the system has been fully released for the first time. So we have a first release, and one of the living labs already had its first test week, which was actually taking place last week, where we gained quite some interesting information, quite some positive news there. Mainly, we saw that in order to fine-tune, because we first tested the Nestle Pladis use case, which is mainly concerning the identification of co-loading and backhauling opportunities. What we noticed is that it requires a lot of fine-tuning to understand what are preferable collaborative journeys. But we learned a lot in the first test week, that's for sure. And we are very enthusiastic about what will happen in the next test week that we're expecting. We're now wrapping up all the feedback, making sure that we can release a second version of the software so we can retest and plan again. Now, for the other living labs, in the coming weeks, we have also different testing weeks planned. So again, hopefully there we will also gain some success to make sure that at least for the 4 living labs that we have identified, that we have proper test data, but also proper working algorithms that facilitate these use cases. Now, that said, I want to thank you for these 20 minutes where I could give a brief explanation about the different living labs within LOGISTAR. And if you have any questions, feel free to shoot. Thank you very much.
Thanks very much, Miguel. And I think it's worth pointing out about the living lab, the testing of the living lab 1, the Nestle Pladis one. I think it was a week's worth of testing, and I think it did go well. I think they liked the dashboard displays. They were very intuitive. They could use them. And I think one of the concerns they had was to do with the way routes were calculated. It was the routing that was really not quite exactly as they should be. And I can understand why, because Nestle and Pladis currently do their planning manually. They don't use any vehicle route scheduling, any vehicle route planning software at all. They have some system support when it comes to approximation of travel times, so they can build their routes with some sort of software support. But it's really, they rely on their manual planners to understand their business and to function as well as they can. And I think that's one of the problems with the vehicle routing software generally, is that the manual planners have a certain flexibility that perhaps the vehicle route planning software doesn't have. So if a vehicle gets back at 2 minutes past 5, the vehicle route planning would reject it because it's after 5 o'clock. Whereas the manual planner might say, well, that's probably all right, we'll take that. And there's certain elements that the vehicle route, the manual planner will know the customer and what they will accept, what they won't accept, and it's very difficult to put that into a piece of software. What we're trying to do in LOGISTAR is to create the route planning system that builds in the sort of preference learning of the planners, and that gradually builds up so they can try and replicate what the planners are doing. But it's early days yet. Those systems, I think, will start to develop and improve, and hopefully with the subsequent testing we will get some better solutions. I don't know if you've got any comment on that, Miguel, if you've got anything to add to that. I don't know if you're on mute. Sorry.
Can you hear me?
Yeah, that's good. Yeah.
Yeah. Well, I agree to what you said. I mean, the first testing was preliminary, so some first good conclusions, mainly on output and user interface, and definitely collaborative routing is more challenging than individual routing optimization. That's something I've learned, at least from the testing.
Yeah.
So, but we're making progress, and I think any round of feedback is a way forward. So, so in that sense, I agree with what you said.
I think it's also important to know that this is academic research. It's innovative research. And there's a big gap between innovative research and the practicalities of operating a very complex supply chain operation for a commercial company like Nestle and Pladis. And there is this imbalance between the two. So I think there is that complexity there. I know that we've got to a stage now where we've got a question and answer session. I don't know if anybody has any questions. I'd be very interested to know what you think of the system, and whether you think we're heading in the right direction. And we're getting to a stage where the system is developed, so it's going to be difficult to change if you think what we're doing is wrong. But what we're currently working on is exploitation of our results. And trying to develop commercial and key elements of the software that could be commercialized. And I think the question now is this system useful in the market? I think that's a fundamental question. What I'd like to do is just share a screen, if you wouldn't mind, and just. This is the agenda, so we're very much on time at 4:10 Central European time. And if I can get it to move on, there we are. This is what we think in terms of market development. We believe that LOGISTAR would be very useful within large logistics service providers. We call in the UK, we refer to 3PLs, third-party logistics companies, but let's call them logistics service providers. This is what we really mean. So they can more efficiently plan. And also within 3PLs or logistics service providers who want to subcontract their loads. We think it's also for shippers who undertake their own load planning and are operating with their own transport equipment. And we think it will assist them to more efficiently plan. So this is who we think our target markets are, but I'm wondering what you think. Are we addressing it correctly? And what sectors would be most suited to LOGISTAR? I don't know if anybody else is going to could comment on that. I don't know if we've got any opportunities to question. To have a question and answer session, or perhaps somebody could unmute and speak. I know there are people watching on YouTube, and
maybe you can ask Andrew. Maybe you can ask who wants to speak. That he puts it in the remarks on the side, on the blue.
On the blue side,
a message.
Yes. Well, if somebody would like to say anything, that would be much appreciated. Make any comment about what we've been doing. and any thoughts that they have. I'm in the absence of. I'm going to say something very contentious because I can see Alex is on. Is in the audience, Alex van Breedem. And I'm going to say something very contentious, Alex, because I think LOGISTAR doesn't need a trustee or an orchestrator. I think that LOGISTAR, if you have collaborative companies that can have a contract between them all, and the way LOGISTAR is set up, each of those companies has to approve the collaboration, the collaborative route that LOGISTAR has produced. So they just have to tick, and the individual company then is functioning. That route is then, if they both companies or three companies agree that that collaborative route is acceptable, they can then send it off between them, and they don't actually need a trustee, because within LOGISTAR there is this Shapley value calculation. It doesn't have the financials. It uses some generic cost information, but nevertheless it uses the Shapley value to create an apportionment between the various deliveries or collections on a route, on a collaborative route. I don't know if Alex, if you have any comment on that. Do you think you might need? I'm going to give you broadcast permission because I like to hear what you have to say. Maybe Alex isn't there after all. Alex, you are here. Okay. I'm just wondering how we can help you to talk.
Alex, you have permission to broadcast, but you cannot speak probably.
Perhaps unmute on the top left.
Yeah, unmute on the top left, maybe, because I gave you permission.
Microphone.
But you can put the micro on.
Okay.
Sorry, I gave permission to Alex.
Yeah.
But on the left-hand side in the top, you can see a microphone. Yes.
I can't turn on audio. No. Okay. It's going to be difficult. So we have to rely on questions. If anybody has anything, I'd be really appreciative if you would respond. I know that if I may, I'll just go and share my screen again because I have some other points. Fernando, I think Alex has issues with his micro. I think maybe he has. Yes. Okay, not to worry. I'm going to show another slide because as well as that, I'd like to know what sectors, I don't know if retail or automotive might be a good, or we looked at chemicals. We think maybe the chemical sector might be very suitable for LOGISTAR. It's reliant on having sectors that will that will have companies that manage their own transport. If those like parcel companies or something like that, if anybody subcontracts and on a non-dedicated basis and just says, well, you know, this is my load, this is my the load I need to ship. Here you are, to a third-party company, logistics service provider, and they go away and do it. It's not really the area for LOGISTAR. But if you have control over your fleet, then I think it's most suited. But there's also another slide which I wanted to show, which is, I feel there's some really a unique combination of LOGISTAR features. And again, I'd really like to know what people think, whether this functionality is important to potential users. First of all, this is a combination, because individual functions will have, they'll be existing in other packages. But the fact this is all in a one system, I think, is where the uniqueness is. For instance, first of all, it's in a cloud-based system, which a lot of software already is, of course, but it eliminates the silo concept. It's using artificial intelligence to produce accurate travel times, which again exists in many software. It takes into account open source data, but this is limited at the moment. But in the future, there's the potential to include things like the different times of the day, different days of the week, even different days of the month or year. There'll be different speeds on roads. So it's using historic probabilities of using historic data to find out what the approximate travel times are to approximate travel times are to get a more accurate picture of how long it takes. And obviously, by reducing by being more accurate with travel times, then you're using your asset much more efficiently. We've mentioned before that it's looking at all loads in real time across multiple operators. So it's taking a daily plan for all the companies, and it's looking at planning that individually, and then putting the two together. Because if you just look at collaborative routes, how do you know how efficient it is? You can only do that by comparing it with what it would have been had a company done deliveries individually. And we're looking at all this cost and KPI comparisons, distance, time, and so on, using the Shapley value. The event prediction with Internet of Things devices. There's built in this replanning in response to various events happening, any delays or accidents or breakdowns or whatever it happens to be. It's got preference learning techniques in there. It's got predictive functions. It's got negotiation techniques. It's got the synchromodal component, and of course it's pan-European. So can somebody tell me if they think this functionality is likely to be important? Is this something that companies would work with? If we could get collaborations going, is this a way of trying to start the physical internet in real time? So I'm not getting any questions. I'm not getting any responses. So I don't know, is this the end of the project? Because I can't get any more comments from anyone.
Andrew, if I could just interact a little bit.
Oh, please.
I'm not sure everyone can talk, and there's not a lot in the comments, but something I noticed was a question from Dirk, whether the system needs to be adapted to each individual company. And that's maybe a good question, because for every living lab that we have in the project, we have actually a very different use case. So for the moment, everything is developed according to the liking of the living lab. When commercializing, can we make that more of a generic system, let's say, or what's maybe your view on that?
Well, I think
one of the questions I see up here.
Yeah, I think I can't see any of those questions. I'm sorry, Miguel. I don't know where you saw that, but I don't know if I've got them. I'm looking on the right-hand side at questions.
You see on the right-hand side, Andrew, you see in the blue part.
Yeah, I see responses from Alex, and I see Fernando, and I see yourself, but I can't see anybody else. Alex said, sorry guys, I'd love to react, but obviously he can't. Yeah, I mean, at the moment, the LOGISTAR system is a mixture of different things for the different living labs, and it needs to be brought together into a whole. So we have a system that will test out Living Lab 1, which is the collaboration, horizontal collaboration, backhauling, and vehicle fill and so on. We've got the synchromodality system. We've got the ETA. Alex, hello. You're on the camera. Are you able to? I can see you're on mute. Can you switch your microphone off on top left? Your microphone's off, but we can't hear you. No. Oh, that's a shame. I always love having a conversation with you, and I wanted to be controversial. I'm sorry. I don't know what we can do, but it's nice seeing you anyway.
I cannot put you on, Alex. It's on the left-hand side, but probably. Sorry.
No. Okay. I don't know what we can do at this stage, Dirk. I think we probably have finished. I'm not sure we're getting much in the way of response, which it could be to do with the system, I'm afraid. I don't know, but this will be the last user group meeting for the LOGISTAR system. But I'm hoping maybe in the end of we'll have to try and undersee your miming. Can you mime or something? We'll try and do a bit of lip reading. But okay. I think when the project finishes at the end of September, I'm sure we will try and host a major end of, whether we do it online or in person or something, but we've got to try and host it. Fernando said that he's here. Can I make him a presenter? Do you know how to do that, Dirk?
I made already Alex a speaker, but I see that something is wrong with your audio or whatever.
Can you hear me now?
Yeah, Fernando, we can hear you there.
Yeah, I think it's when you go back, you need to allow the tool to use your microphone. So then maybe you can go out and then back, but then you need to allow the system to use your microphone. If not, it's impossible. It's when you are prompted, you are asked, and then you need to allow the system. You have done that. Okay, so then this is not the physical connectivity, it's the digital interconnectivity. I'm sorry for this, but I was following this video on YouTube, and I wanted to jump in, but I could not help you. Sorry for this, well, Alex.
We've come to 3:30 anyway, which is the end of our session.
I'm sorry.
But we presented. We hope everybody found it interesting. And yes, thank you very much for joining us. And please get in touch with us if you have any comments. We really, really appreciate any question, any comments you have. Thank you very much indeed. So I think, Dirk, thank you very much for moderating. And that's the end of our session.
Sorry, I couldn't get Alex in, but thank you very much, you all, and all the speakers for helping us. Thank you very much.
And I want to tell you, I was following you on YouTube, but I could not follow everybody at the same time. So then you was mute, and you look great, always smiling, Andrew. That's really nice. I wanted to tell you.
Thank you very much. All right.
Thank you.
Bye-bye.
Bye-bye.
Bye. Bye.